let us look into this problem now from Resnick and Halliday. The question says, figure 227 shows several graphs with unlabeled axis, means axis name is not given. So part A is, which graph would best represent velocity as a function of time for an object moving with constant speed? So out of this graph, we are to select those graphs which represents that the object is moving with constant speed. So constant speed means ds by dt constant, let us say that is v naught. When we shuffle like this and integrate both sides, v naught is constant, so we will keep outside the integration limit. So t is equal to 0 to t is equal to t. Let us say at t is equal to 0, the object was at s naught, and at t is equal to t, it is at s. So your equation becomes s minus s naught, v naught into t, that is s is equal to v naught into t plus s. So what kind of equation is this? S is variable, t is variable, s naught is constant. So it is displacement as a function of time equation. But this is of single degree. T is having only one power. So it is a straight line. So we should look for the straight line in this graph. So which all are straight line in this graph? One is C, one is A, and one is B. These three graphs are continuous straight line. F is straight line in segments, in two segments. One from here to here and then from here to here. So as per this equation for part A, if we say, give the name y-axis as S and x-axis as T. So A and C is definitely following these two equations. So A and C will be the representing graphs where the object is moving with constant speed. That is one thing. Now, since the level is not given here, and if we go with ds by dt as v naught, we follow this equation. And ds by dt we know is representing the velocity. So if we rub this s and rub this t, and we say that this represent y-axis now represent v and x-axis representing t. So this one is a constant speed graph. B is the constant speed graph. So that also follows your part A. So B will also be the answer for part A. So A, B and C is the graph representing the object moving with constant speed. In F graph we cannot tell about that, even if we take it as S, this one as S, y-axis as S and x-axis as t, we cannot tell that this is a constant speed graph, because till here it is fine, it is following this equation, straight line equation. But from here it is changing the velocity in another direction. So it means it is having some acceleration. That is why the velocity direction has changed. So F we cannot predict at this space. So A, B and C will be the answer for your part A. Now let us go for part B. Which graph represents best, or which graph best represents velocity as a function of time for acceleration given by A is equal to plus 3t. So acceleration is given as a function of time, 3t. So acceleration is changing with time. And which way it is changing? T increasing, A is also increasing. So from this equation we have this information that acceleration is continuously increasing. So we are interested in knowing velocity against the time graph. So acceleration we can write dv by dt integrated 0 to t time. Let us say at 0, t is equal to 0, velocity was v0, and t is equal to t, velocity is v. So our equation will comes out finally three t square by 2 plus v naught, where v naught is constant. What kind of equation is this between v and t? It is a quadratic equation, so it will be a parabola. So now go and look for parabola in this graph. So we can see this one is parabola and this one is parabola. That D and C is the D and E is the parabola. Now let us examine D now. Let us examine D now. So what is happening here? In D, if you see, at t is equal to 0. So let us first say this is v and t, because the equation is between v and t and parabola. Okay. So at t is equal to 0, velocity is 0. So our v naught will be 0. So our equation remains v is equal to 3t square by 2. This will be our equation. Now, this we have derived from acceleration is equal to 3t, which is continuously increasing. Okay. This graph is in between v and t. So we have labeled y-axis as v and x-axis as t. So what should happen? your dv by dt is basically the slope of this graph on each point. This dv by dt is equal to 3t or a is equal to 3t will be the slope of the graph at each point. So here the slope is this at this point, the slope is this at this point, so what you can notice, let us go, you can see that continuously the slope is increasing because this angle is increasing. As you go up further, your slope is increasing. Slope is increasing means acceleration is continuously increasing. So this is obeying. This one with V naught as 0. So D is the graph for 3T. So one answer will be D. Let us try to, yeah. So one answer will be your D for part B. Now second parabola is here. The graph is in V and T. So in this parabola what is happening? Slope is gradually decreasing, decreasing, decreasing. Here it becomes 0 and then it becomes negative. But as per this equation, slope should be continuously increasing and positive because T cannot be negative. So your E will not represent for part B. Okay? So your answer will be D. When your y-axis is V and x-axis is T. Now the question comes for part C. What is part C? Which graph best represents distance as a function of time for a constant negative acceleration? It's constant negative acceleration. So what does this mean? Your dv by dt is minus a, where a is a constant. So you will reach to this equation. So this will give you the output of V is equal to V naught minus AT. Which graph best represent distance as a function of time for a constant negative acceleration? Means we should take this as S and this as T. So we should further bracket V, we know that it is Vs by dt. So this will give you an output of S naught plus V naught into P minus AT square by 2. S is varying with T, so it is a function of displacement with respect to time, and this is a quadratic equation, so it will be parabola. So you have two parabola, one is this D, one is your E. So what is, if this is S and this is T, dV by dt is equal to minus A. dt S naught plus V naught into T minus AT square by 3. Okay. So if we differentiate it, means if we reach to this stage from this equation, let us focus on this equation. What is happening over here? Your velocity is gradually decreasing in the positive direction. Okay. But ds by dt is that slope on this curve, means on this curve E, at each point so your velocity you can see is gradually decreasing, means your slope is gradually decreasing, which is true. Slope here is more, slope here is less, 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 and then it becomes 0, and then it goes negative. So your this equation, your this graph, E graph is satisfying for the part C. Here I am repeating once again. S against T is your this graph, that is parabola. As the time increases, from here if you see, as the time increases, the slope is decreasing. And then here the slope becomes 0, and from here onwards the slope negative and increasing gradually. So these two equations satisfy this part. So for C, E will be your answer. When the graph we are representing S as y-axis and T as x-axis. Now, in part D, graph best represents velocity as a function of time if graph E shows distance as a function of time. It is saying if this is the graph, the E graph, is the graph again graph between S and T, means distance in time. So which graph out of E is representing best as velocity as a function of time? Means this one is is velocity and this is time. So we should see this equation for that. We are working now on part D. We are working now on part D. So we should look for this graph, V0 minus 80. So what kind of graph is this? This is a straight line, right? With a negative slope, minus 8. So which one is in this graph, out of these graphs, which one is the straight line with negative slope? So you can see this line, this straight line, that is C graph. C is the graph which has a negative slope and is a straight line. So this is satisfying your this equation. So C will, for D, C will be your answer. That is one. If you want to examine others, here if you see your V is continuously increasing, means, and is having the positive slope, but this equation is having the negative slope, minus A. So A cannot. This also will not, F will also not, because if we see from here to here velocity has increased, means acceleration is positive. And after this, it is following this equation. So if we consider this as a continuous graph, then F will not be the solution for D. So hopefully you understood the concept of solving it. Any doubt, you can discuss directly with me. We will jump into the next questions.